Hi guys, Harry here. Welcome to Scrap Science. It's been a while for the heavy water project, but at this stage, over the last few weeks, I've been really slowly electrolysing our water sample down in this jar, and now, today, we've reached the point where we have less than 50 millilitres left. And that's a good point because now that we've got less than 50 millilitres, we can transfer all of our water into this smaller cell, which should be able to electrolyse down the water a little bit faster, and also hopefully won't lose as much to evaporation and stuff. I showed you this cell in the last video. I think what I had was a couple of solder electrodes I made from like the lead tin 50/50 solder. I've switched my idea since then because I read online that iron metal actually has a really good separation factor between deuterium and hydrogen, which is exactly what we want when we're concentrating heavy water. So I got a couple of iron nails. You can see there we've got our iron nails either side of our solder anode. So with two iron nails here, which we'll use to separate the deuterium from the hydrogen, hopefully it will work quite well. So that just slips in there, that all seals up, and I'll remove this tubing from this jar, stick it in that hole there, and hopefully this will work exactly the same as this, just on a smaller scale so we don't lose as much heavy water. So before we actually go ahead and transfer all of our precious water sample that's taken 15 months of hard work to concentrate, what we're going to do is we'll just take off this tube, which I was using as kind of like a condenser for any stuff that had evaporated out. It'd all like condense in here and then come out the other end. Got a couple of drops coming out, which is good. I could recover it. I'm going to replace this, not replace it, but transfer it, use it in this cell as the condenser for this one, and I'll seal that now so that we don't lose any of this to evaporation currently, and we'll silicon all of this up so that it's nice and sealed, ready for electrolysis. And all I'm going to do to seal the lid is I've got a silicon gun here, and I'll just add a bunch of silicon all to the top of that. Probably need both hands for this. And so that's done. That's all well siliconed. Hopefully that'll remain sealed for the whole time that we'll be using the cell. I forgot to mention this before, but I accidentally made a mistake when I was doing the wiring. I made the red wires the cathodes, or the negative ones, and the white wire is the anode, which is a little bit annoying when I'm going to hook it up. I'll just have to remember that. And now that the lid for this container is drying, we can finally do the exciting bit, which is transferring all of the water from this cell into this cell. I'm going to do that with just a pipette to transfer it across because I don't want to spill any. Ideally what I'd do is, with all this water, is distill it and then like purify it and then stick it in here with a little bit of extra electrolyte. But you know, every time we distill it we lose a little bit of it, and so I think just transferring it straight into this thing here should do well enough, because when I added electrolyte to this one, I only added like less than a teaspoon of sodium carbonate, which hopefully isn't too much for this this cell to handle. We definitely don't want the sodium carbonate to crystallize out as we like keep decreasing the volume of the water, but I don't think that should happen, so I don't think we really do need to distill and like redissolve some electrolyte. Should be good. And that right there is all the water we've got left after 15 months of concentration. So hopefully it contains quite a bit of heavy water. That'd be very nice, which we will separate out over the next month or two, or maybe more. So to transfer it, like I said before, we'll just suck up a little bit with the pipette and transfer it into the new container. And I'll keep doing this until all of the water there is transferred into there, and we'll see if it all fits. Now you probably can't see on camera, oh yeah, a little bit, because of the colour of the container, but all the water that I've transferred from this container into this container. It's very, very full, like nearly right to the top, which is not something we want because our lid, all right, it has to go in to the container a little bit, and then the electrodes are going to take up some of that volume and raise the water level, and it's not going to be all that good. So what I'm going to do is I'm going to transfer a little bit of that water into this vial, and then hopefully once we start reducing the volume in here, I'll just re-add that water in a little bit later, and that should work quite well, I hope. And I've transferred about 10 mils of water out of this container, stuck it in that vial there, and now the water level in this is a much safer level, I think, and it should be ready to go to be electrolyzed, seeing as it's already got a whole bunch of electrolyte in it. So I've put the cell together, and while the silicon certainly isn't dry yet, I think the cell's actually good to go to start further concentration. You can see I've put this beaker on the outside, just filled it with some water for some extra cooling the cell, because now we don't have like all this extra space in the jar for condensing water. We need to keep the cell very cool. So I'll go ahead and put this straight down into the big coolant bath and connect it up to the power supply. Now that I've connected it all up, it is electrolyzing away happily. We've got the condenser tube going right over to another little container over here, which should catch any water droplets, and we've got it hopefully hooked up correctly to the power supply. We've got around 400 milliamps flowing. I've set that as the current limit, and we've got a nice low voltage of 3.6 volts because the electrolyte is nice and conductive, because we have quite a bit of electrolyte in there. In my experience of electrolysis over a large period of time, over the last year, I've found that 1 amp of current continuously will destroy about 10 mils of water per day. So at the current we've got it running at now, 400 milliamps, it'll probably destroy 4 milliliters of water a day, which with the 40 milliliters or so that we've got in there will probably take around 10 days, maybe 2 weeks, given the fact that the current might drop off a little bit as we reduce the volume. Also, I'll have to add in that extra 10 mils, so maybe a bit more than 2 weeks. I'll leave this running until we've got a really small volume of water, which I'll then do a small scale distillation of it using just like a couple of test tubes, and then we'll transfer that into the next cell, which I've got ready here. I've also got another iron cathode for that. It's pretty much the same as the other cell, it's just a little bit of a thinner tube that'll only hold around 5 milliliters. So I'll just wait around for the next 2 weeks for this cell to electrolyze down. You won't have to wait that long because I'm going to make all of this into one video, so you'll only have to wait a couple of seconds. And here we are 2 weeks later. The cell hasn't finished electrolyzing down. We've got a fair way, it's down to 15 or 20 milliliters. I had a look just before, but I'm going to leave the water in there for a little bit longer to try to get that volume down as much as we can. This condenser tube that I've been using seems to have been working pretty well. Because we're running it at such a low voltage and current, there's not too much water that boils off, or evaporates off I should say, but there have been a couple of drops that have collected in this little container that I've got for collecting any water vapor, which I will put back in the cell periodically, but really there's only like a drop in there, so it should be fine. We've had the cell running at a pretty steady 4 volts and 400 milliamps. It hasn't changed much over the entire 2 weeks that I've been running it, so that's also good. The electrodes haven't fallen apart or anything. Anyway, I'll probably leave this going for another week just to really reduce the volume down as much as we can with that cell before we attempt to swap the water out, because every time we swap the water out we lose a little bit inevitably. Also, I forgot to mention before, but if you remember last episode when we recrystallized some sodium sulfate to use as the electrolyte for all of the future electrolyzing down that we'd be doing. I tried that and it really didn't work. The electrodes seemed to fall apart and kind of short out the cell all the time. So I re-distilled the water. Obviously I didn't film that because I thought, well, we've done enough distillation in this series. But anyway, I replaced the electrolyte with the sodium carbonate that we had before, and that seems to have been going really, really well. I only added like, I don't know, maybe a gram of it, so that shouldn't crystallize out, hopefully, when we reduce the volume down, but we're going to have to distill it at some point. And in order to distill it, we can't use our big distillation set to distill like 10 milliliters of water. So what I've come up with is I've set up this thing. This is just a test right now to double check that we can distill small quantities of water with this kind of setup. What it is just a couple of test tubes. One of them will have our heavy water in it. Right now it's just got normal water. We've got this long tube that goes straight into another test tube, which will be submerged in a beaker full of cold water. And I've got a heat gun, which we should be able to just point straight at this test tube. This water will hopefully boil, and we'll be able to collect it all in the other test tube. And hopefully with a small setup like this, we'll get less loss of our heavy water than we would with a regular distillation setup. Now, while that didn't work, I've just remembered that I have these little glass vials which have a flat bottom, and I think they're made of borosilicate glass, so that's pretty good. I reckon we can put one of these on like a hot plate and then just distill like a little bit of water out of that. They're a lot thicker than the test tubes we were using before, and I think that might solve the bubbling problem. We'll see. Alright, let's try this. I'm sure we can get this to work. I've had to like prop up the hot plate now because I keep shortening this condenser tube and now it doesn't really bend correctly. I've had to just keep that on an angle so that it properly heats that vial. But if we turn the hot plate on, yep, hopefully that will start to boil and actually distill this time. That'd be really nice. Alright, this seems to be working. The boiling's a little bit more jumpy, but we are condensing some stuff. If the camera focuses on the right thing, yeah. You can see a couple of drops in that condenser tube. So that's good. Yeah, look at that. That's what it's meant to be doing. Very good. So it seems like we may have just made a small-scale distillation that actually works. See, nothing's leaking out the top here. We've got stuff condensing down the tube, and we've got stuff actually distilling over, dripping out of the tube there. So, excellent. So while this seems to be great and everything, it is quite tricky and very slow. Really, like it takes, this is less than a milliliter distilling and it's been going for maybe 15 minutes. So what I think would be a better option than like distilling all 15 milliliters that's left in there would take, like, we'd have to do this more than 15 times, so that's not a very good option. I think right now we should distill what's in there using like a large-scale distillation. We shouldn't lose too much at this stage of concentration, and then we'll save the small-scale distillation stuff for when we're down to like 5, 2 or even 1 milliliter quantities. I'm thinking if we distill that water now and then add like just enough electrolyte so that it doesn't crystallize out until we get right down to like these quantities, we won't have to do one of these distillations until right at the very end. So I think that's a good option. So this seems to have worked perfectly. It's just about done, and you can see all of the water has been distilled pretty well. And I've got the latest heavy water concentration cell out. We'll go ahead and pipette whatever's left in there into our round bottom flask, which will then set up to distill, and we should be able to get around 15 milliliters hopefully out of it. And that is it, that's all that's left. Maybe it's a little bit more than I thought there was, but hopefully we'll be able to distill that now. I'll just go ahead and distill this. I won't film it because you've seen enough distillation in this series. Actually, something weird that I've noticed the distillation is doing, I don't know, can you see right down there? Right, every time there's a drop, you can notice that the water kind of shimmers down the bottom a little bit. Normally that's due to like when you drop salt water into water because of the different refractive indexes. And the water's looking a little bit cloudy, so I'm not sure that this the distillation is actually working all that well. I don't know. We'll check it out when it's done, but I don't know if it's pure water coming across. I definitely think this is a good idea to double distill this, because look how cloudy it is. And it's got a bunch of, I don't know what that is in the bottom, but it didn't distill very well. We got around 18, 19 milliliters, so that's about what I expected, so that's very good. We'll just go ahead and I've washed out this round bottom flask. I'm just drying it out in the heating mantle now, but once that's dry, we'll stick this back in and re-distill it, and then hopefully it'll be a bit clearer. Once again, it's come over a little bit cloudy. You can't really see on camera, but I've compared it to like another beaker with regular water in it, and it does seem quite cloudy. So I checked the conductivity with my multimeter. I checked the conductivity against my demineralized water, and the demineralized water was actually more conductive than this stuff is. So it tells me that there's really no ionic contaminants in this water that's coming across the distillation, but I don't know where that cloudy stuff's coming from. And like it keeps leaving the round bottom flask coated with something or other. I don't know, but maybe should I just distill it again and see if it clears up? Yeah, I guess so. And it's not perfectly clear, but I think that will do nicely. I'm now just adding some sodium carbonate electrolyte, just enough to still be soluble in 2 milliliters of water. Hopefully this will last us right to the point where we do have 2 milliliters left. And so I'll get this cell ready again, and we'll just continue electrolysing down. I'll get back to you once we reach another interesting point. Alright, another week has passed. We've been running this cell at approximately 200 milliamps for the last week, so I'm pretty sure by now the volume that's left in here should be down to 10 milliliters of water. So what I've decided to do at this stage is remove all the water from this cell and put it in an even smaller cell, which I've got here. This should hold, I'm pretty sure, around 5 milliliters of water, so we'll be able to put half of the stuff in here straight into this container, and then I'll store the rest of it in these little vials ready for later electrolysis. You can see I've got in that cell, I've got the 2 electrodes, the iron nail as a cathode and the 50/50 lead tin solder as an anode, and we've already got our electrolyte in there because we did that just a while ago, so we can just directly transfer it into there. I'll seal up the top with the gas vent tube, and then we'll just be able to run that cell over the next week or so. Probably can't really see down in there very well, but there's not much water left, so that's very good. And there we have it, all of the enriched heavy water has been transferred into this vial. I don't actually know how much is in here, probably a bit less than 5 milliliters, and then there's a bit less than 5 milliliters stored in these 2 little containers here. So what I'll do is I'll add the vent tube onto the top of here, silicone it all up, and then we should be good to start concentrating this down. What I'll do with this is concentrate it down, whatever's in here, 5 milliliters, down to 1 milliliter, and then I'll swap that stuff out, store that in another one of these vials, and stick what's in these 2 vials in there, and we'll concentrate this stuff down later. And there we are, that's all been siliconed up, so I'll let that dry for a couple of hours. It won't be completely set, but by then hopefully we should be good to just start electrolysing that down further. So excellent. So we're a few hours later and we're doing some testing just to see if this cell works properly. You can see in there I figured out before that it would foam a lot. Early on when you put water in one of these cells, it tends to do that. So I've had to break the seal and remove most of the water that was in there, and then try again, reseal it and run it at a lower current. So the current that I've got it running at now is 70 milliamps roundabout, and you can see there's quite a bit of foaming. It goes like right down there all the way to up here, but it seems to be under control, and I'm pretty sure it should die down once the reaction gets going. So I'm going to leave that to do that. At the current we're running it at now, it should destroy about 0.5 milliliter in a day, so it'll take a few days to reduce this amount of water to what I want to reduce it to. So really I'm just going to electrolyse down that little bit of water, replace it with these samples that we had, and then hopefully in a couple of weeks maybe we will be down to approximately 2 milliliters of water remaining. Once we reach that stage, we'll have to re-distill the water, obviously, because then it'll be saturated with sodium carbonate, and I think we might have to move to a different cell design, maybe a smaller one even. But I think that's enough for this video. We've done a fair bit. We are actually nearing the end of the heavy water series, seeing as we've only got really like a few more milliliters of electrolysis to finish it off. But you know, maybe I'll make a couple more videos as we approach the end of what it's taken us 1.5 years. But till then, see you later.